Hey, Daddy. Welcome back to Data Unscripted.
Hey, or how's it going?
Good. And today we're talking about a core concept in data development, which is data transformation, sometimes called data modeling. To get started, Daddy, how do you define data transformation?
Yeah. So at its core, data transformation is basically the process of converting data from one format or structure into another one. Think of it as taking raw ingredients and turning them into a well-prepared dish. Okay, so you're taking raw data and converting it into something more useful and consumable for your needs. These needs could be for data science projects, business intelligence, ad hoc analysis, and so on and so forth.
Yeah, makes complete sense. And some examples of data transformation that come to mind are removing duplicates from a data set or joining two tables such as customers and purchases using a common key like user ID. What are other examples of data transformation that you can think of?
Yeah, sure. So a few examples come to mind. For example, filtering, which is basically removing irrelevant data or outliers. It could be type conversion. For example, you change the data type from a stringified text date into the actual date format. It could be aggregation. You could take individual, for example, a sales transaction
Mhm.
and summarize them by day or by product category.
Yep.
It could be normalization. You can scale numeric value into a common logarithmic scale. That's super useful mostly in data science projects.
Mhm.
And enrichment, you could take some column, add perform calculations on it, like calculate profit margins from revenue and costs. And of course, this pivot, you could slice and dice the data in various dimensions for specific analytical tasks. These are just a few examples.
Great, great, got it. Makes complete sense. Yeah, common question is why is data transformation a separate step from data analysis or other usage scenarios? What's the benefit of implementing a data transformation process as opposed to just doing it every time you do some analysis?
Yeah, so that's a great question. So having a separate transformation layer from your presentation layer has a ton of benefits. First, we're talking about reliability and consistency. When you transform data in a dedicated step or a dedicated layer, you ensure that everyone in the organization is working with the same version of your organization's ground truth. So imagine if each analyst had to clean and transform the raw data themselves, you'd end up with inconsistent results
Mhm.
and duplicated effort.
Right.
And second, it's about efficiency, right? So by transforming data and storing it once in a ready to use format, you're basically saving tremendous amount of time. Instead of data scientists or analysts or data engineers spending 80% of their time preparing data,
Mhm.
they can focus on the actual work, the analysis, building ML models, so on and so forth.
Yep.
Third, it's about consistency and documentation. When transformations are separate and well defined, you can easily track the data lineage. You can understand where each piece of data comes from and how it was modified.
Mhm.
So you can govern the data, you can document in a single place. And finally, it's about scalability.
Yep.
As your data grows, having a well-structured transformation layer means you can handle larger volumes of data without everything breaking down.
Those are great points. Great points. I've personally seen projects fail because they skipped proper data transformation and didn't do the planning correctly. So let's talk a little bit about the common pitfalls in data transformation. What should our listeners watch for?
Okay, so the biggest pitfall I see is not thinking about the end use case when you design the transformation. You need to understand how the data will be used downstream, meaning in your BI tool, in your ML models, and so on and so forth. Other common issues include not handling edge cases and null values properly. This could easily propagate downstream and impact the end consumers. Losing important information during aggregation, not validating transformation with proper testing as part of the data development and not at a later stage, creating overly complex transformations that are very, very hard to maintain. Imagine yourself going into a 1,000 line query and trying to understand what's going on. And lastly, not documenting the transformation logic and the assumptions. The key is to start simple and just iterate based on the actual needs rather than trying to build the perfect transformation pipeline for day one.
Yep. And speaking of starting simple, could you walk us through a basic example of a data transformation pipeline, something our listeners could relate to easily?
Yeah, sure. So, let's take a common e-commerce scenario. So we start with three raw data sources. The first one is the customer data. Second are the order transaction. And third is the actual product. A typical transformation pipeline might look something like this. First, you take the data, you clean it up, and standardize the customer address. You add country, city, etc. This is just one example of how you can enrich customer data. You convert all the currency values into a single currency. You join the orders with the customer data into one single normalized table. You aggregate the daily sales by product category. And finally, you calculate the customer's lifetime value. This creates a clean, analysis-ready dataset that business users can easily trust and query. I can easily send this to the data science team to build machine learning models, for example, customer churn analysis, or myself build a KPI dashboard in Tableau based on that data.
Great example. And I think it's also a good place to wrap up for today. Thanks, Dadi, and see you in the next episode.
Sure. Talk to you later.